let's take a look at how we can organize all of the different parts of stoichiometry that we've looked at so far. Now, the basis of the stoichiometric calculations that we've done is all based around one simple fact, that in the balanced equation tells us that we can go from moles of one compound, so moles of A, to moles of B. That's it. That's the one thing that our balanced equation is good. It tells us about stoichiometric calculations. Now, how we get to moles A, or what we do with the moles B, is where sometimes people get confused. So I wanted to kind of organize some things around this. So we can find the moles of A if we know the grams of A. So we can go straight from grams of A to moles of A using the molar mass of A. So that's from the periodic table. We can also use the particles. So if we know the particles, so like the atoms of A or the molecules of A, because we can go from atoms or molecules to moles using Avogadro's number. So 6.022 times 10 to the 23rd. Particles equals 1 mole. That can help us to get from the particles to the moles. There's quite a lot of things that we can use to find our moles. So let's say we have instead we have a gas. So let's say we know the pressure, we know the volume, we know the temperature of a gas. Then we can use our ideal gas law to find our moles. Because remember, our ideal gas law, PV equals nRT. R is a known value. So if we know the pressure, the volume, and the temperature of the gas, we can solve this equation for N, the number of moles. Once we know the number of moles of the gas, then that will give us the moles of A. So if A is a gas, then we can use that to find the moles of A. Alternatively, if we know the gas is at STP, and we know the volume, then we can use the molar mass, or the molar volume of the gas. So remember, there's 22.4 liters equals 1 mole. So this all depends on what we know. So let's imagine that instead that we know that our compound A is in a solution. So let's take a look at if we know the concentration of our solution. Let's say we know the molarity of A, and we know the volume of A. Then we can use the molarity equation. So molarity equals moles per 1 liter to find our moles of A. So whether we're looking at a solid, a gas, or a liquid, we can determine the moles of A a variety of different ways. Once we know the moles of A, then we can use our balanced equation to get from moles of A to moles of B. Once we've found that relationship, so once we've found the moles of B, we can use all of these same relationships to find our grams of B. We can find our atoms or molecules of B, depending on what we're working with. We can find the pressure, the volume, the temperature of B. So we could find any of these, any of those. You'd only be able to find one of those values. So you can only solve for one variable there. We could find the volume at STP, if it's a gas. So, gases. And we could find the volume or molarity of B using the molarity equation. All depends on whether we're talking about it being a solid, or whether we know the grams of the atoms and molecules, whether we're talking about a gas, or we're talking about a solution. So you do have to be very careful. Are we starting with a solid, liquid, gas? What do we know about it? And how can we find our moles? Once we know our moles, how can we then convert that to a different thing? So it's just tracking your steps very carefully. What steps are involved? Do you have any steps that you have to do before you can get it into grams, before you can get it into particles, to find the pressure, the volume, or the temperature? So keep in mind that these are the core steps within the stoichiometry, but you may have other steps before it or other steps after it, depending on what is being asked for.